So last time we were talking about these clastic rocks and the different sizes of these, right? And how these sizes actually will be different types of rocks. So if they're boulders or granules, they'll be what we call breccias or conglomerates. Whereas they're sand, they might form into what we call a sandstone, like this guy here, where you can see the individual particles there. You can see a little bit. Yeah, it might be a little too fuzzy there, not good enough focus. Or you can find out the sandstone. This is a drill core, by the way. Or we can get something that actually might be like a siltstone, which I don't have a great example here. Here's one that might be like a siltstone. You can see the layers in there a little bit, and might be a siltstone. Those ones might be further out. So for example, often these guys, these clastic rocks or clastic rocks, are deposited usually because of some type of energy within it. Places that have high energy, you're going to have the coarser grained materials, because if you have higher energy, that means that sediment can actually be would be deposited, because the high energy is going to take the smaller stuff away and leave the big stuff behind, right? Now the smaller energy you go means that you can actually deposit smaller grain material and then take the other smaller grain material out. So often what we get is we get things like the coarse material, like sandstones and conglomerates, might be like at a beach deposit where you have right there at the beach. Where off the coast, you might have things like clay and silts and stuff like that actually being deposited. So we can get something like a shell, okay? Or then the stuff that's even further out will have the chemical oozes maybe coming out of the ocean because of how low energy it is. And you'll get something like a limestone. So now that would be a chemical rock here, where the ions in the water itself is slowly coming out of solution. And when it does so, it might be coming form what we call chalk, like I just showed you a minute ago, or a limestone, like I showed you with that this rock here, okay, or maybe rock salt, gypsum, chert, and even maybe peat and coal, if you have a lot of organics, right? So these are all types of sedimentary rocks that maybe at one point came from a granite, but because it was weathered, transported, and then deposited to form these different rocks, okay? So clastic sedimentary rocks, like what we already kind of told you about, are formed from once separated grains that have been compacted and cemented together. Okay, so they might have come from maybe this cliff face where the weathered array eroded, transported down the stream into the beach, and then that surface will have that those rocks slowly compacting down, and then over time you might have water flow through that material and then cement it together because of cementation or even compaction over time. Okay. Whereas, now when that happens though, you have what we call a sorting process for these clastic rocks. Sorting occurs because of the energy in a system, okay? So it's the process which the transportation process selects or separates particles of differing class, shapes, or densities. Okay, so what that means is something that is really big, and if you have a lot of energy, it's going to leave the big stuff behind that it can't move, but anything smaller, it's going to take downstream. Okay, and so what ends up happening is usually stuff down near the mountains are going to be coarser material, and as you go down and down into the ocean, you're going to have finer and finer grain material. Okay, or grain size gets smaller. So it's actually sorted by the energy in the system. So something that's well sorted means that it's actually undergone a lot of energy. So usually places like beaches, okay, are great examples of this, or sand dunes are great examples of this. So all the sediment is the same type of sediment and same size of sediment. It's the same rounding of the sediment, because as it moves down, it breaks down and starts rounding it. Okay, so that we would consider that a well-sorted sediment, right? Whereas something maybe up here, it may be something that's poorly sorted. So maybe it fell down off of a side of a cliff. There's not enough energy, so a lot of the small stuff actually is sorted in with the big stuff. So it's something that tends to have less force exerted with it. Okay, so maybe at what we call an alluvial fan, where the water comes out of a mountain and just drops the bottom of the mountain, it's going to have fine stuff, big stuff, everything all there together. Okay, and then you can have stuff that we call moderately sorted, which might be something in between, maybe in a river, where one day it's strong current, so it has moved the big stuff. One day the current's a little bit less because there's not as much rain, so you have less current, and so you have this this mixture of what we call a moderately sorted sediment. Okay, and so the grain size or the grain characteristics will change through the deposition. So if you have an angular grain, which means it hasn't undergone very much weathering. Whereas if you have a rounded grain, it's going to be slowly moved a lot, so all the edges are going to break off of it and slowly become this rounded grain. So for example, I showed you this breccia that I had before, with all these really jagged clasts. That tells us that this rock didn't the grains itself didn't get transported very far. They might have just fallen off the edge of the mountain and then cemented back together, right? Whereas this conglomerate, the one that I showed you earlier with all the different gravels in it, have very rounded pebbles in it, which means that it's probably been moved a lot. Each of these individual grains have been moving down in a river system somewhere and slowly rounded over time, right? So we would consider that a mature sediment with the rounded materials and an immature sediment with that angular materials, right? So the sorting also has an impact of this. So things that are poorly sorted, we usually call it less mature. And stuff that is very well sorted, maybe it's all the same type of sand, all quartz, because all the other stuff has been eroded away. Okay, so good examples of this is a beach deposit where you have lots of interaction. Might be a very well-sorted sediment, whereas an alluvial fan, where we have that stuff coming right outside of a mountainside, might have lots of different class, lots of different sizes, and therefore it's what we'll call less mature sediment. Okay, so the composition of these clastic or detrital materials can change over time. So what the type of mineral that's inside of it will tell us a lot about the source rock, right? So quartz sand often can be in river systems, beaches, or sand dunes because they're very resistant to weathering. So they end up in places, things like that. Whereas other minerals, maybe like a feldspar or a clay, might not like to be transported or will break down faster over time. Okay, so that's something that's important to think about. So if you look at this one, here's two types of sandstone. The first one up here has tons of different minerals within it. Okay, it's about 25% feldspar, whereas this one's almost purely sand, quartz sand. That's all it is. This is all sand too, but lots of different types of sand, whereas this is all one type. So this is what we call a less mature sandstone, and this one's a more mature sandstone. So this might be a great example of something that was deposited maybe in a river deposit somewhere, or this one would be a great example maybe in a beach or even a sand dune. Right, because it has so much energy, the waves going back and forth every single day, slowly taking away, eroding all the less stable materials and only leaving behind the nice quartz sand. That's the same thing in the sand dune that happens all the time as well too. So those are some great examples. So an arkose is usually a sandstone that has lots of different variety, less mature, and a pure quartz sandstone like this one will be much more mature sediment. Now, deposition is the process in which the transported material, the things that are being moved, will settle. So first you have weathering, then you have erosion, and then you have transportation of a sediment. Now next, out of those three, that's an important process to remember, by the way. You need to first do weathering, then erosion, and then transportation. The erosion is the initial pickup, but the transportation moves it down, and it will continue to move it until the energy is not big enough to move it anymore. And so, or strong enough. The velocity is not strong enough, right? And so if the velocity slows down, then it will actually be deposited. So just like you deposit something in the bank, it will actually be set there and left there, right? Now, it's not going to be deposited very well in that bank if you keep extracting it, so don't do that. If you want to accumulate wealth, you don't keep spending it, okay? The same thing with accumulating sediments. If you want a sediment to accumulate over time, you're going to have to keep adding to it, not keep eroding it and taking it away. Okay, so deposition is that process in which that material is deposited or accumulates. Okay, it will settle out and accumulate. Now, what controls where clastics will be deposited often has to do with the velocity or the energy of the system. Places high up in mountains tend to have really coarse sediments because the energy, even though it might be high, will take away all the small stuff, leave the big stuff that it can't carry behind. And that's the same case in lots of other areas. In beaches, you'll have the sand in the different parts of the river systems. The sand will be deposited in different locations within that river system or in that beach because of the amount of energy that's within that. So, for example, at a beach, you're going to have coarser sediments right there near the right where the interface of the water hits the sand, okay, which we call the shoreline. And then, but off coast, where there's not as much energy, you're going to have finer grain material. And even further off coast, you're going to have finer grain material. And so you'll have that based off of, it will be deposited based off the energy within the system. Okay, so here's an example. Here, there are minerals that are resistant to chemical weathering, can be eroded. They can be picked up and carried and deposited elsewhere. So, for example, there comes the river around here. There's lots of energy here, so we'll erode this bank. It comes out here, and now it's slower here, so it will deposit it over here. Okay? So we have this erosion, deposition. Erosion, deposition. So that's why lots of rivers, they go back and forth, back and forth. They'll erode on one side and deposit on the other based off of the different velocities of the water as it moves downstream. Okay? So sediments deposited by wind, waves, streams are sorted by their size and also their density. If you look at a stream in a beach after a storm, often you'll find this dark lines in the sand. Okay, and those are actually heavier materials, and they're deposited there during storms, where the heavy materials can be up and then deposited behind to leave these black kind of lines. So those are usually iron-rich sediments or something like that that are usually denser. Well, that's important when we talk about mining, because if you can accumulate all that dense materials, you can mine that dense material and then you can actually extract it. A great example of this is gold, and we'll talk about that a little bit more later. So that gravity pulls the sediments to the ground or bottom of the stream or the ocean, but the wind or rushing water pulls sediments sideways, attempting to keep them aloft. So the heavier stuff will go to the bottom of the actual bed, right? So the larger and denser sediments require more wind, stream energy, or wave energy to stay afloat, and therefore they'll be sorted based off that density or the velocity of the system. Okay, so I'm going to give you an example of this. So gold, which tends to be dense, right, tends to form in very large clastic sediments, but it's not very dense. Therefore, small pieces of gold may deposit it with the larger particles. So if you're going to look for gold, you're going to want to look for a place where there's lots of gravel, because that's where the gravel's bigger, has higher density, well, not higher density necessarily, but higher mass, and so it will fall out of the bottom of the bed. Well, that's also where you'll find the gold, because the gold also, because it's denser, will fall out to the bottom of the bed. Okay? Therefore, we should look for gold in gravel bars that are left behind in the future, right? And so that would be a great place. So people actually all the time go panning for gold, and you want to find that in places where the sediment is deposited. Okay? So and more in the gravels than in the sands. Okay? You can still find it in the sands, but not in high abundance there. Okay? So the rock that weathered is to begin important. So if the rock that was mechanically weathered to make the gravel did not contain any gold, you're not going to find any gold in the gravel, right? So you need to know what's upstream. So if you have lots of igneous rocks or metamorphic rocks where gold comes from lots of times, and then downstream of that, you might find gold in the rivers. Okay? So that's why up near like Morro Mountain and the Wari Mountains, people go panning for gold because there's igneous rocks up in the mountains there. Morro Mountain itself is an igneous old volcano, right? And so the rivers downstream might have evidence of gold, and they do find them. They can go pan for gold up in that neck of the woods. Okay, so you find it because it's concentrated in those gravel deposits. So upstream is the granite, where the gold can originate from, and come downstream. Now I could go mine it in the granite, but remember, granite, that ore or that gold has to be concentrated. So the sedimentary processes can now concentrate that gold downstream. So it can concentrate it in the gravels there. Here's where maybe the quartz veins or the granite, the gold's coming from, deposited down, and it's going to be deposited in the places where the sediment is deposited on the sides here, and that's where you should be looking for the gold, right? So it's where that concentrated material is. So that's a process in the sedimentary process that can concentrate material that we can then mine. Other places like that we can mine are places where sand and gravel are there. We use sand and gravel every single day. It's in our roads, it's in our building material, it's in cement. So we need places where we can have high concentrations of sand and gravel. Places in our neck of the woods, we have tons of sand and gravel because this used to be a big beach in this area, right? So we can mine in almost any place around here and get good concentrations of sand and gravel. Other places you might have to look for that. So for example, up in Wisconsin, you might find places where they had old glaciers, so that have deposits where you have that sand and that gravel, right? Or here's an example in Illinois, which this is an abandoned shell deposit where there used to be a lake, dried up, and now there's shell left behind, and so they can mine that instead, so where it's concentrated. So if you have that ore body slowly eroded away, what's going to be actually left behind is that ore that we can then mine. So these are some economic minerals that can be found in clastic sedimentary deposits like quartz, like sand and gravel. It can be used for computer chips, construction, glass. Diamonds can be there for jewelry. gold, silver, lots of things like that.